Okay. All right, you should be having your notes in front of you that are called Applying Systems and Mixture Problems 6-5. And our essential question today is, what can I use to help with a word problem? As you know, there are different things that you can use to help yourself with a word problem. Mostly any kind of pictures that you can help visualize how to organize things, maybe drawing some pictures or maybe putting a table together to put some things. So what I'm going to do is we're going to do two problems today. And we're going to look at this first one I've written out for you there if we read it down below. So let's follow along as I read it. It says a coffee shop sells a mixture of Kona beans and Colombian beans. Kona beans cost $8.40 per pound and Colombian beans cost $6.90 per pound. How many pounds of each should be mixed to make 5 pounds of coffee beans costing $7.80 per pound? Now, if you look at the front board, you'll see that I've made a table. It's a 4x4 table where you have 4 columns and 4 rows. So I'm going to give you a moment to draw this table. Please use the same labels that I have. It will make it go much smoother. We will have the entire front page for this one problem, so hopefully you have room to work underneath. Like I mentioned a moment ago, it's good to have things to help you organize yourself, to see what's going on, and take information out of a word problem so that you can see what you need to write where. So let's kind of take a look at this here. Now if we go back to the sentence, it says Kona beans cost $8.40 per pound. So what I'm going to do is I'm going to take that $8.40 and I'm going to find Kona beans and I'm going to write 8.40 because that's the cost per pound. The next thing I see is $6.90 per pound is the Colombian. So again, I'm going to write that there, 6.90. And the last thing we have, I want to make 5 pounds of $7.80 per pound. Well, we know the $7.80 per pound is going to go down here to the mix because that's what we're looking for. And amount, I want to have a total amount of 5. So let's have a quick discussion up here about what goes in these 2 boxes above the 5. So let me just kind of do a quick drawing here. You don't need to draw this. Let's say this container has 5. It's filled all the way up to the lid and it has 5. If I reach in, if I put my hand in there and I just grab a whole bunch and I take it out, if we don't know how much this is, what could we call this if we don't know what it is? We know it's an amount, but we don't know what the amount is. That's what we call X. So we're going to say that a part of this 5 is X, and so where it says Kona beans, I'm going to put an X there. Now, where it says Colombian beans, it's really going to be this. It's going to be whatever, Colombian beans is going to be this part here. All of this left over. All of this part here is going to be the Colombian beans. So basically it's going to be 5 take away X. So that's what I'm going to write down. 5 take away X. That's where all of these numbers come from the paragraph. Then after that, we really can't get anything else from the paragraph, but we can get the total cost on our own. We know that if you buy a certain amount of something and it costs a certain amount per pound, we would just multiply those together to get the total cost. So let's do that. So this would be 8.4. I'm going to drop the 0 times X. This would be 6.9 times 5 minus X. And the last one would be 7.8 times 5. Okay, so now let's go back to our scenario here. It says if we take Kona beans and Colombian beans and I mix them together, I'm going to get this mix. So basically, I'm going to take these two and I'm going to add them together and they're going to equal this third one. So I'm going to write myself an equation based on that. Let me move my little drawing here out of the way in case somebody wants to look at that for reference. And I'm going to write my equation. So I have, oops, left the slide behind. There we go. 8.4x plus, right, that's the Kona beans. Now here's the Colombian beans. 6.9 times 5 minus x. That is going to equal 7.8 times 5. Okay, so now we have our equation. We're going to take the things that we know. We're obviously going to try and solve for x. It's a multi-step equation. We're going to take the things we know and try to pull it together. So I'm going to go to the next page. It's going to be the exact same thing that we see. We've already practiced about how to get rid of decimals, correct? So when I look at this one, since there's really only one decimal after each one of these, I'm going to multiply each one of these times 10. So 10, 10, and 10. And I'm going to rewrite what I have. So I have 84x plus 69 times 5 minus x equals 78 times 5. All right, so now we have to do some simplifying and put some stuff together. I'm going to try and keep ourselves straight, so I'm going to draw a line here to keep things where they are. So I have 84x plus, I want to distribute 69 times 5. Well, I got to work on the side here to find out what that is. 45. That's 345, so I'll write that down. Minus 69x. That's going to equal, and I have 78 times 5 on that side. That's going to be 390. Okay, I'm going to collect some like terms here. I have 84x minus 69x on one side. So we can work that again. 84 minus 69. And do some borrowing there. So that's 15. So we have 15x plus 345 equals 390. So now we're at a two-step equation. Very simple. Use the property of equality. Subtract 345 from both sides. This goes away. Leaves us with 15x on the left side. 390 minus 345 is 45. Then I'm going to divide both sides by 15. And I find that x equals 3. Now that's reasonable so far. So let's go back. And we know that we know that x equals 3 so far. Well, if our question is how many of each, well, we can see where the x is. I need 3 pounds of Kona beans. So I'm going to write that down. 3 pounds of Kona beans. And Colombian, I need 5 minus 3, and 5 minus 3 is 2. And 2 pounds of Colombian beans. So this is our final answer here. In words, what it is we're looking for. Some of the things that you might notice, if we go back and look at our table, you'll notice that we have these numbers 3 plus 2. And isn't 3 plus 2 equal to 5? And isn't that what we're doing here? We're adding together to equal this, even though these two won't add to get to that because it's cost per pound. But we can see always in the amount, that's always going to happen, that we're going to add these two together to get this amount. If it doesn't do that, then you did something wrong and you got to go back and figure that out. Okay? All right, let's try it one more time. Let's look on the back side of the page. This is actually a very classic problem, more than likely a similar one that you will have when you take the state test. So it says a chemist has one solution that is 60% acid and another that is 30% acid. How much of each solution is needed to make a 750 milliliter solution that is 50% acid? So once again, let us draw our table. And again, we're going to make a 4x4 table. And just like we did last time, I put a little blue dot here. We don't use that corner spot at all. So everybody draw a 4x4 table. And our labels are going to be a little bit different. I'm going to call the first one solution A, the second one solution B, and the third one the mix, because I'm trying to mix them together, right? And then here, instead of price per pound, what do we have that would involve decimals? Percents. So we're still going to have amount, and we're still going to have total. So these labels on the side there, but that percent can be dollars or percent. It's going to be some kind of decimal amount that's going to help us to do this. Give a minute, let everybody catch up, make their box, put their labels. Okay, so let's put everything in that we need. So a chemist has one solution that is 60% acid. So when we write 60% as a decimal, we put 0.60. So that goes there. They have another one that's 30% acid, so we'll make that one 0.30. How much of each solution is needed to make a 750 milliliter solution that is 50% acid? We'll put 0.50, and we want to end up with 750. So that's the information that we get from the paragraph. We get nothing else from the paragraph, just this. Everything else we have to use deductive reasoning for. Again, we don't know how much we need out of the first one, so we're going to call that X. And the second one's going to be whatever our total mix is going to be. We're going to subtract this X from it. And we can see if I was to add these top two together, X and 750 minus X, the X's would go away and it would equal this. So that's what we're always looking for. Okay, now to the total column. We're going to multiply the first two. So 0.6, I'm going to leave the 0 off because we don't need it, times X. 0.3 times 750 minus X. And 0.5 times 750. And again, we're going to add these top two together, and it's going to equal the third. So we're going to write ourselves a sentence. So here we go. 0.6x plus 0.3 times 750 minus x equals 0.5 times 750. So that's our equation. And now that we've got our equation, we can kind of ignore what's going on here so that we can work on this. So I'm going to do that. I'm going to go to the next page here. So I have it all ready to go. And we want to get rid of the decimals. We've practiced that already. So each one of these has one space. So we're going to multiply everything by 10. If we multiply by 10, that'll get rid of it. And we don't need to multiply more than once, because see how this is already multiplying? This 0.3 is already multiplying to that 750 minus x. We just need to multiply the front one. We don't need to multiply everything, because then that would be multiplying by 1,000. And we don't want to do that. So if I do that, that'll move the decimal place over 1. So that'll be 6x plus, moves it over 1, 3 times 750 minus x equals, again, moves it over 1, 5 times 750. Again, I'm going to draw a little line here so we can kind of keep things straight. Okay, let's do some distributing. So I have 6x plus. I want to give 3 to 750. And again, if you cannot do that in your head, that's okay. We're just going to work it on the side here. And we get 2250 minus 3x equals, and again, we have 5 times 750. We're going to work it again on the side. And we get 3750. And we have a multi-step equation. So if we take 6x and subtract 3x from it, we will get 3x plus 2250 equals 3750. And again, we're going to solve like a two-step equation. We're going to use our inverse operation. So we're going to subtract 2250 from both sides. That's going to make this 2250 go away and leave 3x equals, and we need to subtract these from each other. So we get 1500. Then we're going to divide both sides by 3. Still working to get that x alone, because anything over itself is 1, so that goes away. And then 3 goes into 15. We don't have to do it on the side if we don't want to. 3 goes into 15 5 times, and the zeros come with us. So at this point, it's saying that it needs 500. Let's see if that's a realistic answer. Okay? We need a total of 750. So 500 is reasonable. So 500 is going to be our solution A, and our solution A is the 60% acid. So let's write that down. 500 milliliters of 60% acid solution. And so since this is 750 minus x, so it would be 750 minus 500. If we subtract those from each other, we're going to get 250 milliliters of 30% acid solution. And we can see 500 plus 250 is the total amount of 750. Remember, we're going to use words when we have a word problem. Make sure that our answers are in words. Remember that word problems, your answer needs to make sense. It just can't be done because you're going. Make sure the answer you're getting applies to the problem. Okay, you know what your homework is up on the board.